Well, welcome and thanks for joining us today. My name is Kevin O'Donovan and I'm the host for this session. Now, before we begin, some quick housekeeping. You know, one of the values of IoT World Days is that they allow us to be live and interact with each other in real time. So for those of you joining live today, you'll see a chat window on the right-hand side of your screen. So please use that to interact with anybody else who's in here live today. So to start off, if you want to type in there where you're joining us from today, just tell us where you are. Now, under the video window on your screen, you will see Q&A. If you have any questions as we go through the session, please do type your questions into the Q&A. If you type them into the chat, we may not necessarily see them. So chat for all the attendees and questions and answers into the Q&A box. Now, this track should run for about 50-55 minutes, but we'll make sure that we get you out in time for the fifth session today. And, you know, this Industrial Metaverse IIoT World Day wouldn't be possible without our sponsors. So a shout out to GE Digital, Intel, Hitachi Vantara, Ursula Leo, Siemens, and Dark Pulse. Now, for those of you who are familiar with IIoT World, you'll know what we get up to, but just in case you don't, IIoT World is a leading authority on industrial IoT. It's a digital media outlet bringing the latest industrial Internet of Things, virtual conferences and content to a global community of about 280,000 people worldwide. And, you know, IIoT World covers various different industrial IoT across multiple verticals. And online, you know, IIoT World curates a lot of virtual events like this one. And today we have over 2,500 people registered, and there's probably 400 to 500 people watching each session online. Now, that's the housekeeping out of the way. Before we begin, just a quick one. My name is Kevin O'Donovan. I am on the board of advisors for IIoT World, and I'm spending my time looking at new technologies and looking at the art of the possible, and then working with companies as to how you bridge the gap from what's all the cool stuff you could do, but what's relevant for them today. And as we've been going through today, you've heard a lot of different sessions on the industrial metaverse, what it means to people, how they see it going forward. And for the next session, I'm delighted to be joined by Steve Garbrecht, the Director, Industrial DataOps and IoT at Hitachi Vantara. And the title of the session is The Industrial Metaverse Needs a Strong Data Fabric. Steve, for folks that may not know you, can you do a quick introduction, please?
Yeah, thanks, Kevin, and welcome everyone to this presentation. I've worked for a lot of popular industrial automation companies for about 30 years. And I kind of started off in control systems and in operation software. I helped to manage historians and MES systems through my career. And, you know, as I kind of noticed what was going on with the industry, you know, a lot of IT solutions and technologies make their way into industrial areas. And they start off in commercial and business type arrangements and even in consumer type applications. And they kind of get morphed and change to meet the specific needs of an industrial organization and start to take on new capabilities as part of that. And you know, the industrial metaverse, you know, is a very interesting area coming up here. And I wanted to, you know, talk a little bit about some of the concept of a data fabric, which is more of an IT term, and some of the more professional data management type techniques that are coming in as part of this, right? So as part of that, you know, one of the main points of this presentation I wanted to talk about with the metaverse, it's very data rich, and it really introduces a lot of problems that companies need to face from a data management point of view to really be successful inside of this area, and have a strong data fabric, if you will. And I'll explain a little bit about what that is to support the AR and VR applications that really make up the metaverse is really going to be important going forward. So my point of this presentation is to keep it very practical and to look maybe at an aspect of the metaverse you hadn't really considered so much when it comes to rolling out these solutions and making them sustainable as part of that. So we can all agree the industrial metaverse is truly a game changer for equipment intensive operations organizations, where digital twins and AI-driven analytics provide a real-time immersive experience for operations people to optimize their work environment, to save costs, provide more instruction to less experienced workers as part of that. We've seen what's happened with COVID, for example, with the mass exodus of workers in the industry, and to drive sustainability and net zero initiatives as part of that. One example of this, for example, is digital replicas of wind turbine assets that can be designed and placed in precise locations where the weather conditions will provide the most optimal power production as part of that. But at the same time, taking into account the forces on the structure to reduce the effects of wind and water pressure on the structure, for example. And there's also examples of inspection processes, for example, with power poles and bridges that can be automated with drones and computer vision, which can prioritize work activities, keep people out of harm's way, and help to reduce insurance premiums and improve the reliability of these critical infrastructure operations. This is something that Hitachi has been well known for in the past few years. Then the entire act of collaboration can be digitized, where people avatars, or a new term we're hearing of digital phenotypes, are interacting in virtual design environments with maintenance and production facilities to speed up group decisions and better harness creativity across previously siloed teams and processes. All this is possible from the metaverse and some of the promises that we're hearing for the solutions that are coming to be inside of it. Now, a little bit about Hitachi. Hitachi's been active in the metaverse for many years. We've applied visualization techniques to understand complex subjects. For example, data patterns to support, and also in the support of regenerative medicine applications, to be able to understand these things more thoroughly through vision and analytics. We've also helped to develop wearable sensor arrays that provide the ability to improve workplace safety with continuous monitoring of vital statistics of employees to understand the strain on the human body and what this undergoes, and provide immediate feedback to managers and supervisors to enable the human in the loop more effectively as part of that. We've also created virtual plant tours to help people understand the business we're in and create transparency across what we do as a company overall.
Steve, if I can ask a quick question, you mentioned you have a digital replica. In many of the sessions earlier, people were talking about digital twins. Is that the same in your world or slightly different?
A little bit of a different approach to things. So digital twins, we definitely have a good capability in digital twins to provide a simulation of the real world environment, machines and people and processes, and apply a digital overlay to that. But we also start to treat the digital twin kind of as a data hub, a broker for data coming in from sensors and other information, and then merging that with different types of data coming from simulation packages and also from IT systems to provide an additional capability for disseminating that information and making it work more effectively with analytics. So, we've kind of taken the digital twin a little bit beyond its common representation to also help in the data management of things as it applies to twins.
Okay. Thank you.
Great question. Yeah. A couple of examples here of what we've done with Hitachi. So for example, GE Hitachi, which is a joint venture, has created a virtual reality training simulator that's used in nuclear power generation plants. We use this to train operations personnel in the cost-effective and safe manner of changing fuel rods. So using exact replicas of operations consoles overlaid with virtual reality training simulation, we can provide a realistic and immersive training experience for operators. From this, you can create virtual training schools, much like what you have with the Starship Enterprise holodeck, for example, where instructors and students interact in real time to accomplish the training activity. And also realistic problems can be presented to the operator that they must take action on. So preparing them for doing their job and feeling more confident as part of the overall process. Another example.
Sorry. There's a couple. We've got the interactivity going. There's a couple of questions just popped up. And if I may ask, Samir has asked, could you please define what you mean by data? You know, is it any classifications or characterizations specifically designed for the metaverse world?
It is. And, you know, you think of data and data management is kind of falling into structured data and unstructured data, right? So structured data, you would see things coming from, you know, from historians, from sensors, from relational databases, you know, kind of things that have a, you know, kind of a continuous structure to them, you know, kind of, you know, data elements. Then unstructured are things that are coming even more for the metaverse, like video and audio, for example, and picture data. So those unstructured elements need to be merged with the structured ones to provide a context inside of the metaverse. And I'll talk a little bit also as we go forward here in the presentation about how that basically creates the content that you're talking about. So, you know, over the years, we've talked about the progression of data management. So, you know, data becomes information by being able to apply more capabilities to it or more information around it. That information becomes knowledge, you know, which is kind of disseminated in dashboards, in analytics that are created for people. And when you start to see patterns in that knowledge, it becomes wisdom for the company, right? So you can come with a standard operations procedure or a common way of doing it. So, you know, think of data in that progression. You know, as you're enhancing data along the way, it goes to the wisdom that you need to be able to run your operation. And the type of data that we're talking about here with the metaverse is very much AR and VR based. Yeah.
And if I may, the questions are coming in. Tom has asked, are graph databases part of the technology stack for your data fabric?
Yes. Graph databases are something that's considered as part of that. You know, different techniques in machine learning and AI can be applied to help in the development of the applications as part of that. So yes, I would say yes, they are.
Thank you.
Yeah. Okay, great. So just to kind of continue here a little bit, we've also created and designed augmented reality headgear to aid in the assembly worker of the technician in doing their job in the most effective manner. So these ergonomically designed are for user comfort and portability, where these AR glasses are easily integrated with stored data, right? For example, work instructions, design documents that provide the ability to see that at the point of work to get the job done. With the addition of telecommunications equipment, a remote expert can also be brought in to help out with the problem, providing additional levels of confidence to how the job has been done effectively and in an effective manner and a safe manner as part of that. And you can see examples on YouTube of the different things we've done in this space, for example. So I think everybody can agree the industrial metaverse use cases are all very much highly focused on augmented and virtual reality. You know, there's some of the new technologies that are kind of ubiquitous inside of this environment. For example, you know, product design and engineering teams can use augmented reality to accelerate the design and prototyping of new products. This is an increasingly attractive option for companies that are keen on reducing product development costs and improving time to market. Also, hands-on training is one of the clearest and most widely accepted use cases for the metaverse technologies, where virtual reality can bring people together without the expense and downtime associated with traveling to a central training location. And the training and learning space isn't just a matter of visualizing the activities that previously took place in a physical object or a physical space. AR and VR training can also go one step further and make the invisible visible for training purposes. For example, to illustrate the problem, what it may look like, and provide guidance to what to do in case of a fire or a spill or a break in a machine, more effectively using this technology overlaid. Also, virtual services for hands-on work is also becoming very powerful as a use case for AR, and virtual guidance for people faced with unfamiliar or technically challenging hands-on work, where virtual overlays can provide them with vital information on what to look for, where to focus, and how to complete the task most successfully. Also considering networking and socializing and creating as an opportunity. As we discovered during the pandemic, work means more than just simply getting on with the task and doing your work. Many of us found we missed out on the social side of the workplace by being out of the office. From serendipitous encounters at the coffee machine to just hanging out with coworkers and friends to learn about what's going on inside of the operation. Could the metaverse could also be a way to provide more work-based socializing and make that more meaningful for people? Now, I want to really stress that AR is the application that we're talking about a lot in the metaverse, but content is really needed to make it useful. This includes vast amounts of data and information from sensors, documents, user guides, work instructions that are provided at the point of work for the technician and the operator to use the actual equipment. And not all this information can come from the cloud, and edge processing and storage requirements need to be considered to really make these effective. Also consider the technician as a sensor of some sort. They're generating new information, such as notes on what was fixed, checklists that were signed off on, and other data collected by just walking around the operation and doing their work. All this forms a record that's uploaded to the system that can help to make operations more effective in the future, as well as providing the needed documentation for compliance purposes, for example. But let's not kid ourselves. There's been established metaverse collaboration tools in use for many years, right? And this is the practicality of things. These include picking up the cell phone and the radio to talk with someone about a problem that you have. Instant messaging or collaboration tools that have existed for many years have been there. Conferencing technologies allow us to share audio, video, and chat in real time to get remote assistance as part of that. Also, documentation systems and workflows applications have been used to move things along as it comes to solving a problem. And all these technologies will come forward into the metaverse and be as part of this new immersive environment that we're building. So we shouldn't discount the fact that things are coming forward that already exist today. But there are different problems that come with this. And a lot of the problems are data focused in how we're approaching it. So the metaverse as a whole is set to push data usage by 20 times in the next 10 years. This will test the capabilities of 5G and also ushering the need for 6G networking as part of this. This all leads to data problems that need to be addressed and overcome to really be effective in metaverse applications. One of the big problems, and this is not just in commercial applications, but also very much in industrial, is data privacy. It's seen as the #1 hurdle in commercial application environments for industrial today. For example, imagine gathering biodata using a biosuit or some kind of a LiDAR type of an application to look at line operators' movements to be able to improve the operation. Doing that in a union shop, right? You have to make sure that you're completely protecting that data from an individual point of view when you're using it. Also, over 77% of managers distrust the data they must use for decision making. Now think about this. If you have applications that are giving you instruction and prediction of what to do and prescription, if the data isn't good, then that's a big problem. Also, anyone who's played a video game in a virtual environment knows that when the network slows down, you get dizziness and vertigo can be induced, which makes the experience extremely unpleasant, right? So once again, performance is a big problem that needs to be addressed. The industrial metaverse is also based upon the application and development of AI and analytics as part of that. 70% of the time that's needed to create these type of applications is just in the integration and data prep for machine learning. So to be able to get an effective way of producing these applications quickly and efficiently, that needs to be addressed. So data management is something that everyone really needs to be thinking about when it comes to enabling the industrial metaverse to be effective.
Steve, a couple of questions piling in here, and I think you've answered some of the first one. Samir has asked, data management is not clearly defined today, or there's different definitions. And he was asking, could you say a few words on how we will handle and harness data in the metaverse? What will be the main challenges? So I think you've called out a couple there, but I suppose anything else you want to add? You know, the concept of privacy. The new Meta Pro headset detects your facial movements, so it can detect. It can detect if I have things like depression or ADHD, but it can also detect my biases. So that whole data privacy thing is fascinating. But I suppose to Shamir's question, anything else in terms of data management, how we see it today, and will it change in the future?
Yeah, no, that's a great question. You know, one of the things I try to do in my role at Hitachi is to kind of introduce IT and business related approaches to managing data and how they might be injected into industrial as part of that. And you know, in banking and insurance for many years, for example, there's been the concept of data privacy and being able to curate data no matter where it is, and be able to manage it effectively across the cloud, the data center, and the edge, which in our case for the edge would be the industrial plant or the the industrial facility as part of that. You know, data movement is important as part of that. So if you have a lot of video files and heavy data requirements for analytics, you know, where do you execute those things most effectively? And when you start to get it into scale, you know, how do you look at the costs of doing that in the cloud, you know, data storage and processing requirements versus doing it on-prem? So the automatic data movements become very important as part of that, where it becomes an automated process to make sure the data is at the right place at the right time. Data lakes are also an important thing. You know, data lake is something where you basically, put all of your structured and unstructured data together into a single, set of repositories that can be all cataloged together and maintained and managed together as part of that. So, all these things, as you start to get into, what we call big data, start to be very important and something you should look at. And with the metaverse, the data is definitely big data, and it's getting a lot bigger as part of that. So all these things need to be managed in the context using some of the professional techniques that have been used in business today, for example. And I'll go into a little bit more detail on that in some of the coming slides here.
Oh, thanks, Steve. And Shiram had asked as well, and I think you've answered a good bit of it, what sort of data adaptations are needed to make existing enterprise data available for metaverse use cases, as you outlined. Depends on the type of data, depends on the use case, but you have to take all that into account, right? It's not just doing the same thing with the same stuff we have today. There will be some changes. Yeah,
a lot of it has to do too with the integration of what we call OT and IT data together. How do you take the data and blend it together, right? To create a new data type or an additional piece of information that didn't exist before that can now give more understanding to somebody to use it inside of the industrial environment. Or maybe you have a lot of OT data that could be more useful if used in other parts of the business, like in the support organization, for example, or the call center, or for marketing that you may be doing for your products, whether you're a oil company or making lubricants, or whether you're a utility that now is trying to get more at hand information for the person who's on the phone with the consumer or the customer of the water department or the power department, to give them more information in more of a customer 360 capability, right? All these things are possible and need to be looked at as part of that. Yeah.
One last question, if I may, related to this. Somebody has asked, how do we improve data trust? A lot of legacy data sets, we have to address that. The metaverse isn't going to change all the data suddenly we trust it. So how do we trust data more?
Oh, that's a wonderful question. So data trust is something that we're very passionate about at Hitachi. To improve the trust, it's kind of a combination of looking at first of all, the quality of the data coming across and making sure that there's a automation in place to check its validity as it's put into the right location to be leveraged by something. The other thing is just to be able to document what the data is, so that more people can leverage it in the organization and feel good that it's been checked by a subject matter expert, or it's going through an algorithm that is basically looking at it to make sure it is correct before it actually goes into a repository or is used for a certain purpose. This becomes extremely important in analytic programming, where you're actually using data sets to train things. You want to make sure that those data sets are proper and correct as part of that. So documenting them becomes as important as part of that. So a lot of this kind of leads to an automation of data management that can be put in place. And I'll talk a little bit about that too. Yeah. Okay, so a little bit about Hitachi. As you can probably gather, Hitachi, our DNA really is data, and we really are passionate about this. We offer trusted and established track records of serving IT with a deep experience in OT that no other company really can claim in the marketplace today. We have a heritage that gives us access to 60 years of IT experience, building data storage and data management systems for large enterprises, and over 110 years of industry domain experience in being a manufacturer of equipment and an operator of operations and utilities in our own right as part of that. Because of this long established expertise, we have an advantage over our competitors, and we know data better than just about anybody else out there. In fact, thousands of mission critical systems today in the largest enterprises use Hitachi Vantara data management solutions to manage their operations and be effective. So we're basically a company that can work with data management, analytics, and industrial all rolled into one as a single provider. That's a little bit of a commercial for us. But let me explain a little bit also of some of the philosophy of professional data management. Data ops is a term that's well known inside of business and commercial today, but may not be that well known in industrial. It's really the professional approach at managing your data to build a data fabric to serve your overall organization. That's where we really want to get, is data as a product for us, a valuable commodity that we use within our organization. Data operations or data ops refers to a new opportunity for those who want to be industry leaders as part of this by leveraging their existing data and making that more effective. Data ops applies to lessons learned from the very successful DevOps movement. And DevOps, for those who are not aware of it, helps to institute agility, improve quality, and increase production success simultaneously in large-scale software development programs, for example. Data ops is a data management practice that brings agile principles to data by improving the cross-functional communication, integration, and data flow and automation between data stakeholders. It works edge to multi-cloud. Data ops is about having the right data at the right place at the right time. And just like DevOps, data ops relies on a high degree of automation and collaboration to make sure that the data is working effectively. To help to manage this, we came up with a portfolio for the metaverse called the Lumada Industrial DataOps portfolio. The Lumada Industrial DataOps software manages data in the same way a production automation system manages material and processes. So it considers the total quality management or TQM aspects of data to ensure that it's enabled as a fundamental building block for operations and business use. Now, this includes things like securing the collection of operations data, managing the data definitions, which may include storage, version control, exchange with other systems, and the overall master data associated with that. Management of data resources, including the registration, exchange, and analysis of resource information, the scheduling of data processes, also the execution of analytic assembly projects using digital twins and ML services to train models. And also analytic dashboards and performance analytics where it makes sense to use them. And also data track and trace to present a complete history of the data sources, combinations, transformations, and more that made up the information that you're using to make sure you can track back and see where problems first came about, fix them both in the short term and in the long term. So data ops offers a data fabric-based approach to enabling and accelerating business across IT and OT use cases as part of that. So it's really a key enabler of what we could do for the industrial metaverse.
And Steve, if I may, just quickly on that one, a question that comes to my own mind, and now there are a number of other questions lined up, but we'll come to them in a few minutes. You spoke about the use of AR and VR and the different types of data and the data fabric and managing it. We often talk about, well, everything's in the cloud, some of it's at the edge. Do you see a different, let's say, IT infrastructure that's needed does data have to become closer to where people want to use it? Is it all in the cloud? Is it in a cloud? How does that play out?
Yeah, it kind of depends on, and when you do data management in a professional manner, you're taking into account many different dynamics that you're working with, right? So one of the first dynamics, of course, is performance of the systems you're using. So if you're delivering, an AR or VR application locally, to be able to feed that information very quickly into the application being used at the site or at a particular location, you have to make sure that that you have the data on hand quickly to do that. Also, some of these things are mission critical, right? When we talk about analytics. So you have to make sure you have a backup of what may be going on in the cloud locally. So if things go down, the performance doesn't degrade, or if the connection goes away, you've got that capability to still operate. Then comes in the cost of doing things, right? So, when do you do things in the data center that you may have as a company? When do you do it in the cloud? When do you do it on premise? And kind of, managing those data movements that happen so that you're, the concept of cold data and hot data. If you're, if data is going to be used immediately, it's now available and online to be used. If it's not going to be used immediately, it's more longer term storage. Can we offload that information to, from the cloud, so I don't have to incur those cloud storage costs, for example, right? So it really kind of depends on how you have to take into account all the aspects of how you're going to use the data for a particular outcome, and how you're going to manage the costs associated with that too. So one of the things that I'll talk a little bit about as it applies to the metaverse is the use of digital twins. And at the heart of Lumada, which is our software portfolio, the concept of a digital twin, which, as I said, is kind of a data broker between the real world and the virtual world. Our digital twin is really a data manager for the flow of data associated with physical machines and processes. These digital twins can also be embedded one inside another to build a more complex representation of the entire manufacturing plant, for example, which may contain production lines, which contain machines, which contain individual components like pumps and motors and sensors. And all this can create a complete digital representation of what's going on. Now, data can be routed through these digital twins, but there's also the ability to integrate these twins with third-party first principles physics-based simulators. So these are simulation applications that provide a complete representation of the digital behavior of the asset, for example, in real life. Now, by being able to interface these things together, we can allows us to create synthetic data that provides additional details using virtual sensors, of which the data can be easily, which is for data that can't be easily measured in the real world. So, for example, angular acceleration is not something that needs to be calculated. It can't be measured in a sensor directly, typically. So this provides additional information to train the models to be more accurate and predict the outcomes as part of that. So kind of think of the concept of a digital twin that can be used to create data for the development of AR applications and metaverse applications, but then also imagine being able to run it in parallel with your real-time systems and the sensor data that's coming out to constantly compare the should-be behavior versus the actual behavior of the asset, and being able to tune your actual performance of your predictions and prescriptions that are happening by doing that. That's the kind of concepts that we're building in as part of this. Now, we talked a little bit about data. And Kevin, are there any other questions that have come in that we'd like to answer?
There are 5 in the queue, but let's go through some of the industrial use cases you have here, because I think some of them will be relevant, and I'll ask them as we go. Okay, great. I'm going to illustrate 3 use cases, and I'll talk a little bit about the data involved with them, so we can kind of consider this aspect of the metaverse, or what it really takes to pull them off from a data management point of view.
So first, let's take an example of AR for physical product designs, for example. And let's take an example of an automotive organization that leverages industrial metaverse applications for product design. And in this case, they're trying out different engine designs along with the accessories attached to them and how they would fit inside of an engine bay of a car that they're designing. Now, in building an application for this, all of the design documentation for the engine needs to be managed and cataloged for use in the application. There's also different revisions of these design files that need to be tracked, so the lineage of the information needs to be maintained across multiple databases, typically in the organization. Here, our data catalog can help to catalog this information and organize it to keep track of it and provide the ability for others to annotate information to the data sets and documents so that more people in the organization can leverage them. That's a good example. Then in real time, when the team is working on the actual automotive chassis and they're using augmented reality to fit various engine designs into the engine bay, for example, in a virtual environment. Now consider that there are hundreds of point cloud type attributes that are coming from vision systems attached to the headsets that people are wearing. And this needs to be interpreted using visual analytics and a local computing node to calculate the information in real time. So performance is very important. The user may also want to look at the test and maintenance information history associated with the engine or the chassis to validate any assumptions that they're making on how the final engine placement will behave in real life. All of this information flows from existing systems, from databases using a data flow manager, and combines data from two different systems together and creates a new stream of information that can be leveraged within the application. All this is done with behind the scenes so the design engineers experience a seamless environment when they do their job. Now, the building blocks for this include digital twins, fast edge processing platforms, visual analytics, and a centralized data lake to be able to manage the data more effectively. So that's an example of product design.
And Steve, just a quick question. There was one question came in here and it says, how are AR and VR 3D images collected and captured? Any specific tool? They're looking at implementing AR, VR from scratch. So, you know, many people will be familiar with using VR and AR, but some may not. So how do you start creating an AR model or a VR model?
Yeah, well, AR and VR models are specialized applications that will you know, there's a lot of vision-based analysis that goes into it. So, you know, if you're creating an AR application or a VR application for a training activity, for example, let's say we're doing virtual reality training, right? You know, one of the first things that happens is, you know, what are you training on? Because you've got to have a real good 3D representation of that equipment and facility or other things that are associated with what you're trying to do. So gathering that that point cloud information using LiDAR, for example, and video type analysis and picture data, and storing that inside of like an S3 environment. You know, so you got the data available to you, right? But then taking it and documenting it and creating data sets, and that's typically what data engineers will do, and the people who are aligning the data for the data scientists to do the actual work in creating the AR focused applications that would be part of an application. So a lot of that needs to be organized properly, and then once again, there are regulations that come in how you're doing this. You know, if you're using any individual data, so say you're now developing a VR application that's going to mimic some of the movements of an operator, and you're using some production data that you've gotten on movements of people and how they do their job, that needs to be disguised and anonymized more so it can be used within that environment, right? So you have to make sure you're only storing the data that you're using for a particular purpose as part of that. So a lot of that is considered when during the production process and developing the applications.
No, I agreed. And personally, what I've seen with many companies would be if they're starting from, if they have a 3D model already of the building, the piece of equipment or whatever, well, you can take that CAD model and you can then use that in different software tools for being able to display that in AR or a VR environment, and depending on the headset and to your point there, that if you don't have, if it's a brownfield site and you don't have the CAD model from when it was built, you can scan it in. So things like, as you say, LiDAR scanning, lots of photos, point clouds, whatever. So you can then create the 3D model from a brownfield site, and then you use that. So it varies, but there are plenty of different solutions out there that get you off the ground. And again, some AR applications, they may not necessarily need any 3D model at all. Maybe it's just a workflow that appears on the screen. It's text, or kind of click, click, click. It's different. But anyway, okay, sorry.
Yep.
Please continue.
Great point. Thanks, Kevin. That was a great addition. Yeah. So let's take an example now of virtual reality training, for example. Let's consider now the automotive assembly line where a new employee has been hired. So this is an employee who has little manufacturing experience. They may have been a barista at Starbucks, for example, and now they're moving up in their career, and they like to get into the industrial sector, and they're very eager to learn this process as part of this. So can we develop an application to help them? In order to develop such an application, an enormous amount of data is needed to be gathered about the actual production facility in order to generate the game-like environment for training. This data is stored in a data lake and organized for use by the programming team as part of that. As part of the exercise, data engineers properly tagged and documented the metadata, or the descriptive data associated with the data file, so that they're easily accessible, can be browsed or searched by the programming team as they assemble the application. Video footage of the process where animations were created and overlaid is cataloged automatically using AI in a data cataloging software. So you don't have to do that manually. At the same time, manuals and training documents were referenced and integrated as part of the work process. This results in not only the application being developed faster, but also provides a local video storage and content management platform that spanned from the cloud to the development sites to aid in the overall production. Now comes the day that the worker uses the system, and the movement of the data files were automatically scheduled based upon the need for the training of that day, and taking into consideration cloud storage costs versus on-premises deployment needs as part of that. The data fabric made sure that this data was available at the right location, at the right form, to feed the system when it's needed to deliver the training as part of that. Information was integrated also from HR systems, with new employee and personal information redacted, so that things that were needed for the training simulation were used, but only those things that were needed. This results in a training exercise which is more securely being able to store training data for reporting purposes, and provides compliance for government regulations as part of that, for protection of privacy and information related to that. All this data management helped us to make a virtual reality experience that's much better for the participants and the administrators of the applications. So think about the longevity of doing these things as you develop them. Well, finally, let's take an example of a technician in a chemical plant, for example, who's doing some hands-on work. And they've been dispatched to fix a pump in a water treatment facility, for example, in that portion of the chemical plant. To find the right pump, the AR glasses that they're using should guide them to the pump's location, provide safety information on how best to get there, and present the technician with the current state by accessing things like the sensor values from the control system to be able to see what is actually going on. Then maintenance records are also provided to see what the previous problems were and how they were fixed. And then they may even pull up a YouTube video or some kind of a video coming from a local storage to present how to repair this, how to repair in this situation, so they can be much more able to do the job. Once the work begins, the technician starts producing data, and this needs to be stored. So this could be picture data or video data, problems uploaded so that a remote engineer can help out with troubleshooting. Maybe a work order may be required and requested to order parts, which notifies someone in the parts storage area to dispatch a repair kit. All the telemetry data is stored, like the movements made by the technician through their biosuit, for improvements for future work processes and instructions, for example. Also, the verbal and written comments are captured as part of the work record. Resulting checklists are uploaded as they do the work to certify what was done. And the technician supervisor may inspect the work, provides an inspection sign-off before the technician closes up the pump and finishes the job. Then a communication can be established with the central control room operator to start the pump, and the operation is back online. All this required a strong data fabric to pull it off, which included things like being able to combine together instructional videos, geolocation, sensor data, and work manuals with some of the building blocks of sensor integration into the system, data pipeline management, visualization analytics, and integration platform to make it all possible. So what makes this all real possible is the merger of digital and physical worlds together and interactions made in real time. And to be able to provide accurate 3D identification of the virtual and real world objects together in a total solution that's provided. So I hope this has been helpful to kind of look at some of the considerations from a data management point of view and information management that's required to enable the metaverse applications that we talk about. In summary, the opportunity exists today to better enable individual metaverse data experiences to drive projects and scale these solutions. So they're achievable for your organization. They can go from a single plant to multiple plants to your entire enterprise. And you can start to use data as a key component, a valuable asset you can use inside of your organization. So a strong industrial data fabric is needed to make all of this successful. We'd love to help you with Hitachi. If you'd like to learn more about how to build a data fabric and use some of these technologies in your next project or your solutions that you're building, please let us know and we'd be glad to help. And thanks again for all your time.
Steve, come here. Thank you very much. There's about 5 or 6 open questions right now. So let me quickly jump in with a couple of these. First question, Rita has asked, does Hitachi already, do you do anything around healthcare in terms of surgery and for doctors, or is it primarily in the industrial side you guys are?
Yes, we have several business units in Hitachi. We're about a $40 billion organization. And one of the concentrations we have is with our healthcare division that we do a lot of work with. So we actually do a lot of digital solutions for healthcare where it comes to hospital management, also in visualization and AR and VR for those type of applications. So we can help with with the development of those applications, anything from a turnkey solution, but also we can help out to augment your staff to be more effective in developing the solutions. And if you're using contractors for doing things, we can work with them too to provide additional data management and development tools that can help with that.
All righty, thanks. And a question just popped up. There's 2 questions from Jordan that I'll come to in a second, but Dirja has just asked, so Hitachi is a big player in the utility space. What are you doing around control center applications in terms of Dataverse, Metaverse? Is there a way of revisualizing kind of data control systems?
Yes. Around control systems themselves, and
it just says control center applications.
Control center applications. Okay, so we have an extensive portfolio of visualization analytics applications that we can apply for control centers, for example, in utilities. Anything from using AR and VR to or visualization and analytics to analyze foliage growth and be able to plan out work activities to maximize the effectiveness of maintenance operations in the field for cutting trees and clearing back brush, for example, and also looking at the risk analysis associated with that. To also, doing drone inspections, so we can analyze thousands of pictures very effectively using visualization software that we've developed and analytics that can look at and it can be trained basically to identify a piece of equipment like an insulator, and then also a problem with that insulator, for example, a crack or oxidation on it, and categorize that and catalog it so that you can quickly understand where you should be doing your work and reducing risk across your operation to provide uptime. We've also looked at the overall effectiveness of operations and risk reduction to be able to once again analyze all of your data to provide a better assessment of where you should be doing things to improve operations overall. So yes, we'd be glad to follow up with you for questions around that, what we can do in utilities and power transmission and power generation. Okay, great.
There's been about 5 or 6 more questions just flooded in. We're not going to get to them all, but as you just heard from Steve, Lucian and the team at IIoT World will be following up with any of the open questions back to Steve and the team. So hopefully they'll get any ones we don't cover right now will get covered off in the next couple of days. Jordan had asked 2 good questions on technologies that are close to my heart. He asked, in terms of privacy, security, trust, data quality, where do you see blockchain technology fitting in, either permissioned or permissionless blockchain networks?
Yeah, I'm not an expert on blockchain, but blockchain can be applied to storage technology also. So to create a more consistent system of record of what's going on, and also data protection. So we have some data protection technologies that interface with blockchain to be able to provide that storage security and data management security as part of that. So I think blockchain has a place for sure. Just like it does today in financial transactions, for example. Blockchain is very heavily used in banking and insurance, for example, to protect data, to make sure that the lineage of data is identified as part of what's going on. So blockchain, I think, has a place definitely in industrial as part of that. And once again, we've enabled blockchain solutions before, so we can help with that if you'd like to engage us on that.
No, and if I may add, yeah, as you say, there are many industrial use cases right now for both permissioned and permissionless systems, depending on whether they're depending on the use case, depending on the industry, depending on the company. But I suppose that the feature with blockchain is that it's immutable. So you need to figure out what data you actually write onto the blockchain, whether it's encrypted or not, because you've got the whole GDPR and whatever. So as you say, it's a piece of the puzzle, but it's and we'll see more use of it. Now, related to that, Jordan had asked an extra one, wasn't that, do you see any use for enterprise NFTs, non-fungible tokens, in better managing digital twins? You mentioned earlier about your digital avatar. If I meet Steve, if I meet your avatar in Altspace VR tonight, how do I know it's you?
Oh yeah, it's a good question, and I'm definitely you're stretching my knowledge now in non-fungibles. Certainly, there's a lot of technologies that are coming to play here that are used in commercial for different things. That can be applied, I think, into industrial. The one thing that I always kind of stress with people is you should concentrate on the outcome that you want to have happen, right? And then start to bring in the technologies and the data management and the analytics and things like that to support that. So start off with what outcome do you want to do? Is it a supply chain problem? Is it a manufacturing training, a training operation problem, a design problem you're trying to work on? And what outcomes do you want? And then start to apply the things that make sense. And if some of these new technologies start to make sense to do that, then certainly we should start to do that. Don't try to boil the ocean from the beginning with we're going to make everything blockchain and these other whiz-bang technologies that are coming in. Also consider long-standing technologies and how they might be applied to solving that problem.
I agree. Now, I know there's a lot of work going on around NFTs, non-fungible tokens, in terms of a digital sovereign identity for a person, for a thing, an avatar, a piece of technology. But as you say, it's a new field. I find it fascinating, but there's other ways of doing it as well. We don't always have to use the latest bleeding edge stuff all the time. But certainly, I would encourage people to keep an eye on NFTs, wallets, understand what's going on there just as a thing. And the clock is against us, so we've got about 2 minutes, but one very relevant question. This is again from Samir. What, in your opinion, would be the positive and the negative effects of potentially the metaverse on human behavior?
Well, the positive ones are definitely collaboration and being able to work more effectively with others, I think, to augment the ability of people to do things, where you're overlaying information and providing a better work instruction. So, we've seen this mass exodus of people that have left the industrial space. There aren't a lot of people lining up to come back in, right? So being able to to give that better instruction, make the people that we have even more effective, makes a lot of sense. The negatives, I like to think that we continue as a group of people working in industrial to be inquisitive and want to learn as much as we possibly can about how to run the operation, right? I grew up in an era where, people I grew up with, we liked technology and we liked to take things apart and see how they worked. So, I hope that this technology doesn't completely remove us from being inquisitive about how the operation works, to really go the extra yard to kind of understand how things operate, take a little additional training, stretch yourself to go and understand, not just the part of the business that may deal with the equipment, but also how it affects in the supply chain, how it affects the the operation, the customers involved, to continue to become real domain expertise experts as part of this, right? So that's the only negative I could see, and maybe that's a negative for all technology, right? We should continue to learn and become experts as we can.
No, from my own point of view, I suppose it's like any technology. Since back in the Stone Age, some people will use it for good, some people will use it for not so good. That's just human nature. But there certainly are things we need to watch out for. In many ways, I see the industrial metaverse as being just the next evolution of digitalization. Digitalization becomes cybersecurity. It's two sides of the same coin. So there are things we need to watch out for. Folks, I apologize, the clock is against us. There's about 7 or 8 questions we haven't answered. We'll follow up in the next couple of days with Steve and team. But Steve, thank you very much, sir. And folks, we'll be joining the next session in about 3 or 4 minutes.
It's been an honor, Kevin. Thank you very much. And thank you everyone for attending.